Hey, what's going on, guys? Welcome back to my channel. I'm Genie AJ. So today we're going to be setting up the building blocks for a fully declarative NixOS system. We'll be installing the NixOS system, configuring the system for remote access, enabling Docker, configuring Traefik as a reverse proxy, and then finally deploying Immich for self-hosted photo management. Let's go ahead and get into it. All right, so the first thing I want to do is I want to walk you through how to install NixOS using the official ISO image. So in this demo, I'll be setting up on a virtual machine inside my proxmox, but the steps are nearly as identical for bare metal as well. If you're new to NixOS or want to follow along with the official documentation, I definitely recommend bookmarking the NixOS manual. It's thorough and a great reference to have on hand. A good place to start. All right, so the first thing we want to do is we want to head over to the official download page. You'll want to scroll down to the section labeled NixOS, the Linux distribution. From there, you'll just grab the graphical ISO image that matches your CPU architecture. Most folks will want the x86-64 version for standard Intel AMD systems. All right, so I've already created my VM inside Proxmox. It has 40 gigs of storage, 8 gigs of RAM, and 16 CPU cores. Plenty of horsepower for a Homelab setup. Now, if you don't need nearly as much, you don't need nearly as much to get going. NixOS can run on as little as 512 megs of RAM and about 8 gigs of disk if you're going CLI only. But I prefer some breathing room for my setup. So I'm going to boot into the live GNOME environment and I'm going to launch the NixOS graphical installer. All right, first up, I'm just going to select my language, location, and keyboard layout. Then I'm going to enter my user details and check the box to use the same password for administrator account. That just makes my initial setup easier. And since I'm going to be using this as a headless server, I'm going to choose the Node desktop environment. It's just a clean base to build on. Next, I'm going to be enabling unfree software. As the installer notes, skipping this step might cause some hardware to work suboptimally or not at all, especially with networking or your graphics drivers. For partitioning, I'm just going to wipe the entire disk and let NixOS handle the layout. And that's it. I'll just click install, wait for it to finish, check the restart now, and then hit done. All right, so now that everything is up and running smoothly, the next step that I want to do is enabling SSH so that I can access my server from my terminal on my host machine, on my main machine. So what you want to do is you want to jump into the /nix or /xe/nixos directory and open up your configuration.nix file. So once you have your configuration.nix file open, by default, as Nano will be the text editor that you'll use, you're going to scroll down and you're going to uncomment the line services.openssh .enable equals true, and this switches on the OpenSSH daemon. Once that's set, you'll just save and exit. Control X, Y, enter. And then you'll want to apply the changes with running the command sudo nixos rebuild switch. I'm already running as root, so I'm just going to do the nixos without the sudo. All right, now that that's done, we can test it out real quick. I'm going to grab the IP address. So ideally, I'll just configure it as a static IP later through my unified controller. But for now, we're just going to get the whatever IP address it was dynamically assigned. You can see we're running on 20.41, so that's the IP address I'll use. All right, let's try to SSH into it. And it works. All right, remote access is good to go. All right, now that I got SSH access working, it's time to enable one of my favorite features of NixOS, which is Flakes. Flakes make your system config more modular and more reproducible. So to start, I'll edit my global Nix configuration again at the xe NixOS configuration.nix file. I'll add a section under the nix.settings to enable the Flakes and experimental features. So all I have to do is towards the bottom, I'm going to paste this line of code, which will enable Flakes. Once that's in place, I'll save the file and then I'll rebuild the system like before. So if you get a warning about nix.settings not existing, make sure you're using the most recent NixOS channel, like 24.05 or later. So to confirm that your flakes are working, you can try running nix flake tac help. If you see a command list, then you should be good to go. All right, now let's go over our flake.nix file. I already have it created. First, we'll define a simple description up at the top. It's just a label to help identify this flake. Next, we declare our inputs, which is basically the building blocks for our configuration. Looking at it, we're pulling the latest NixOS package channel, unstable package channel, as our base system, and we're also importing the Flake module for the VS Code server from the Nix community. This step is optional. I use VS Code server. It just makes it easy to declaratively enable remote VS Code access. And then looking at the outputs, which defines our system. Here we're passing all of the inputs into our output function, and then we're using them to define a system called NixOS right here. Think of this as like our host or machine config. So you're looking at it inside, we call the NixOS system from the Nix package library. We're specifying special args so that we can access our inputs from within our custom modules later on. And then starting off, we're only including a couple of modules. We have our main configuration.nix, which is our default configuration file. And then we have this default module that is provided by the Nix OS VS Code server. And then here we have a quick line that enables the VS Code server. And this is all you need right now to get started. I have these two modules commented out. We're going to go over that later. Once you're done, you're going to save and exit. And then you can apply your new configuration by running this new command, which is sudo nixos rebuild switch. And then you want to tac flake. And then the current directory, you'll just use dot. And this command builds and activates the system using our flake within the current directory. If everything is configured correctly, you'll be up and running with your new setup within no time. It takes no time at all. When you run this for the first time, Nix will also generate a flake.lock file. And this file is important. It records the exact versions of every input used in your flake, like your Nix package or third-party modules. This means that even if those upstream sources change, your build, your NixOS build, will remain consistent and reproducible. You can think of it as like a snapshot of your entire NixOS ecosystem. It's great for version control. It makes your setup portable for other machines or even people who wants to contribute. All right, now let's set up Docker so that we can start running containers within our NixOS environment. And since we're using Flakes, I'm going to create a dedicated module file, and we're going to call it docker.nix. This keeps things modular and easy to reuse across multiple systems. So first thing I want to do is I'm just going to create a directory called modules, and then I'll create the file docker.nix. And then I'll add the following lines. And this enables the Docker daemon as a systemd service. This is all you really need. It just enables Docker. You'll save and exit. And then I'll include this module within my Flake setup. So we'll reopen flakes.nix. And we'll just uncomment out this line right here to include it within our modules. Once that's in, save and exit, and then we'll rebuild our system using the sudo NixOS. And now Docker should be ready to go. We can just test it real quick by running this docker run hello world command. And if that runs without errors, you should be good to start deploying your containers. All right, we have Docker up and running now. So let's pivot real quick over to users. So we want to create a clean, reusable module for our user settings. This just helps keeps our flake.nix organized and make it easy to apply the same user setup across multiple machines. So what I'm going to do is I'm going to create a new file for my user, which is Genie. I'm going to call it genie.nix. Place it inside my modules directory. Inside my modules directory, I'm going to create the file genie.nix. And I'm going to add the following code. So this just creates a user called Genie, assigns them the bash shell, and adds them to the network manager, Docker, and wheel groups, which just means they can manage my networking, run containers, and use sudo. I'm going to drop a couple of SSH public keys as well for passwordless access. This is essential for any Homelab setup where I want to quickly access my SSH into machines without typing my credentials every time. And I'm just going to put those right there. You can also install packages scoped to this user by adding them within the package list. For now, I'm just leaving it empty, but you could toss in tools like Git or NeoVim. Once you're done, you want to save and exit. And then we're going to go back to our flake.nix file. And you want to uncomment, just as we do with the docker.nix, we're going to uncomment our user module, genie.nix. You want to save and exit. And then we'll just rebuild the OS. All right, and that's it. Your user is now fully declarative and reproducible. Now let's talk about how I'm running Traefik. So instead of enabling it using NixOS built-in services.traefik module, I'm managing it entirely through Docker Compose, but with a twist. I've wired it up to use systemd to ensure that it starts automatically and that it stays running like a native service. So looking at my configuration, this is the exact same configuration that I used in one of my earlier Traefik videos, running Traefik without Docker labels. So if you want a deeper dive into how I have Traefik set up under the hood, including the static routing and the file-based providers, please check out that video. I've also published the full configuration on my GitHub if you want to follow along or reuse it. So what I want to do now is I want to create a module that I'm just going to call traefik.nix. So looking at this module, I'm just going to highlight a few things. So the working directory points to where my compose.yaml file lives. In this case, it's /docker/Traefik. The exec start pre, it just pulls the latest Traefik image every time that this service starts. Super useful when you're tracking the latest tag. Then you have the exec start, which brings the stack up, and then exec stop, which takes it down cleanly when the service is stopped or the machine reboots. So I've also added proper ordering so that the service don't start until Docker is up and running. And then the restart on failure, systemd will automatically try to recover traffic if it crashes. So this configuration gives me native systemd integration while keeping my Docker Compose setup fully intact. So this is perfect for declarative Homelab workflows. Again, if you want to see this setup in action or review the full code, please check out my GitHub and then revisit my label-free Traefik video. I walked through how I have Traefik set up there. So that's the full setup running Traefik with Docker Compose via systemd. Everything's neatly declarative and tucked inside its own NixOS module. So the last thing that we have to do is we just have to include this module within our flake.nix file. So I'll exit. And then I'm just going to add the Traefik.nix module inside my flake.nix file. I'll save and exit. And then I'll rebuild my system using the same command as before. Sudo NixOS rebuild switch. And that's it. Your Compose Managed Traefik instance is now fully integrated into your NixOS system. Fully declarative, automated, and clean. So once your system is rebuilt and Traefik service is live, you can verify that it's running properly with a systemctl status Traefik. It gives you a snapshot of the service's current state, whether it's active, fail, restarting, or inactive. You could also run a Docker PS as well, just to make sure that your services are up and running as well. And then just like with Traefik, I've set up Immich using the exact same systemd approach, managing the container with Docker Compose, but wrapped inside of a custom NixOS module for a full declarative control. This means that I get all the same benefits: automatic startup with systemd, clean service logging, and reproducibility across all my Homelab machines. Looking at it again, my compose.yaml file for Immich lives within inside the docker/Immich directory. And then I've created the systemd.services image module that pulls the latest image, brings the service up, and shuts it down cleanly, all orchestrated declaratively through NixOS. And also, just like with Traefik, all I have to do is add the module to my flake.nix file, rebuild the system, and then Immich is up and running. So if you want a closer look at my compose file or my systemd service for Immich, I got those configs up on my GitHub as well. And that's pretty much all I have for this initial NixOS Homelab setup. Just to recap, we installed NixOS on a Proxmox VM. We enabled SSH for remote access. We flipped on Flakes for full modularity. And then we rebuilt a clean user module to keep our config reproducible and portable. We enabled Docker declaratively. We wired up Traefik with systemd and Docker Compose. And we did Immich the same way as well. If you like this video, if you followed along this far, you now have a solid scalable base to build upon for a modern self-hosted stack. Everything that you saw in this video, including my Flake config, custom modules, and compose files, it's all up on my GitHub page if you want to clone it or use it as a reference. If you're curious about how I run Traefik or without Docker labels, or if you want to deep dive into other self-hosted projects that I'm doing, please check out my other videos on this channel. And if you found this video helpful, please drop a like, subscribe, and let me know in the comments what you're deploying next. All right, until next time.